let's talk about our favorite project management tool, Lean Construction. Lean Construction is pillared by two major concepts. The first being that all parties involved will continuously work to get rid of all forms of waste. The second being that a continuous workflow will lead to shorter lead times. This means a shorter cycle time. Let's consider a standard lumber cutting operation that can be found on a construction site. Here we have 3 workstations that all take 2 minutes to complete their work on an individual piece. At our first workstation, the worker has to measure and then mark each individual piece. At our second stop, a worker uses a saw to cut the pieces according to the marks that were made in the previous station. In our third and final station, a worker has to hammer and nail each piece so that they can be made ready for final installation. Let's conduct a brief experiment on 2 different approaches that we can take to complete a set of 5 pieces of lumber. In our first approach, we'll batch the 5 pieces at each workstation. Here, each worker works on 5 pieces and then passes them on to the next station. The downstream station can only accept batches of 5. Here we see that as Station 1 begins its work, the 2 downstream stations have a lengthy idle time before they can commence their work. Let's see this approach play out in real time. Here we have in and out boxes for every station. Notice how the material gets stuck until all 5 pieces are worked on. The time that it takes one piece to go through all phases and be ready for installation is a whopping 22 minutes. The time to complete 5 pieces is a grand total of 30 minutes. Now let's try a second method to conduct our experiment. This time we'll create a continuous workflow where boards are moved immediately one after the other after being worked on individually at every workstation. By lowering the batch size to just 1, here we see that the wooden boards move along smoothly, with all the workers being engaged and working on a piece simultaneously. This is crucial in lowering the cycle time while also increasing productivity. Let's see how reducing the batch size to 1 works in real time. With this method, the total time to complete just 1 piece is 6 minutes. The time to complete the entire set of 5 pieces is about 14 minutes. Let's check out a comparison in real time of the 2 methods that we used. Notice how the case where workflow is continuous finishes significantly faster than its counterpart. Alright, let's discuss some analytics. First and foremost, let's measure our productivity using the 2 methods. We'll define productivity as the rate of output over unit of input. Our input will be time in minutes, and our output will be measured in wooden boards. Our first method produced 5 boards in 30 minutes, leading to a productivity rating of 0.17 boards per minute. Our second method comes in at over double that value, having produced 5 boards in only 14 minutes for a productivity rating of 0.36. Next, we'll take a look at lead time. We'll define lead time as the time that it takes to complete a production process from start to finish. We'll measure the lead time for a single piece as well as the entire set of 5 that needed to be completed by the 3 phases. Having continuous workflow led to a tremendous improvement in the lead times. Our second method produced its first piece 16 minutes faster than the first method. It also produced the set of 5 boards 16 minutes faster as well. Now let's look at idle time. We'll measure this as the time spent by employees or workstations in which they are unproductive. We'll measure this for both methods. The method where the boards were batched into 5 pieces at one station suffers greatly from this. The idle time here is largely caused by the fact that only one station is active at any given time. This causes the other 2 workers to be idle. Because 2 workstations were always inactive when the wood was batched, 20 out of the total 30 work minutes required to complete the set of 5 were always spent idle. That's over 2/3 of the work wasted. In the continuous flow method, idle time is severely reduced because all 3 stations are at work simultaneously. Here, idle time only occurs at the very beginning and at the very end of the construction process. Reducing the batch size eliminates a total of 14 minutes of idle time. That counts an over 64% improvement over the batch method. The concept of setting work in progress limits and batch sizes is set on the premise of limiting inventory. This allows production systems to make sure that their workers and resources are properly allocated and sufficiently productive in their stations. The best way to create and track work in progress limits is through the use of Kanban, which comes from the Japanese word for signboard. The most basic Kanban board will have 3 columns: work that needs to be done, work in progress with a previously determined limit, and finally, work completed. As a work in progress limit is reached, bottlenecks become easily identifiable and resources or workers can be transferred to ensure that the work is done efficiently and on time. Real-world examples of the benefits of reducing batch sizes and limiting work in progress can be found all over the place. Think of your favorite coffee shop. Most modern coffee shops are focused on providing the shortest wait time possible for their consumer. Thus, they'll start on one drink from start to finish before beginning work on a new one, limiting their batch size and their work in progress.